This is a multiple concept question based on the work energy theorem, law of conservation of energy. Okay, so let us try to solve this. How high a hill can a car coast up if burden by friction is negligible and its initial speed is 110 kilometers per hour? If in actuality, a 750 kg car with an initial speed of 110 kilometers per hour is observed to coast up a hill to a height 22 meters above its starting point, how much thermal energy was generated by friction? Third bit, what is the average force of friction if the hill has a slope of 2.5 degrees above the horizontal? Now the data is given to us. Let us try to do the problem. First bit, how high a hill can a car coast up if burden by friction is negligible and its initial speed is this one? So initially the car has only kinetic energy. By the time it reaches the top of the hill, it has the potential energy. So kinetic energy gets converted into potential energy. So K is equal to UG, where K is the kinetic energy and then UG is the gravitational potential energy. Okay, gravitational potential energy. We know K is equal to half mv square and UG is equal to mgh. Okay, from this two, we can write half mv square is equal to mgh. That means energy initial is equal to energy final. Okay, so h is equal to, from this h is equal to, m cancels out, h is equal to v square by 2g. Input the values. V square, V is equal to 110 kilometers per hour. So I write here, V is equal to 110 kilometers per hour. We have to convert it into meters. So this is equal to 110 into 110 kilometers per 1 hour into 1 kilometer, here 1000 meters, okay, into 1 hour, 3600 seconds. This gives V is equal to 30.55 meters per second. So this value I input here. So 30.55 square divided by 2 into G value I am taking as 9.8. So this gives H is equal to 47.63 meters. Okay, now he is asking how much thermal energy was generated by friction. So for that, what we have, thermal energy means the energy is lost. Actually, according to law of conservation of energy, the entire energy should be converted in kinetic energy. Initially it has, the initial energy must be final energy, but that is not the case here. Some energy is lost in doing the work against the friction. That manifests in the form of thermal energy. So the difference gives the thermal energy. EI minus EF is equal to E thermal. So this is the first bit I finished. Okay, and then let me do the second bit. E thermal is equal to K minus UG. Okay, that means otherwise I write like this, E initial minus E final. This implies E thermal is equal to K minus UG. So K is equal to half mv square and UG is equal to mgh. So half into mass is 750 kilograms, 750 into 30.55 square minus 750 into 9.8 into 22. He gave 22 now, height. Okay, so this gives the value of 188, 288.4375 joules. That means E thermal is equal to 1.88 into 10 to the power of 5 joules in scientific notation. Okay. Now he's asking us to find out what is the third bit. We have to do the third bit. Okay. So to do the third bit, what we require, what is the average force of friction? So first we have to find out the distance that we find out from the geometry of the figure. This is 2.5 degrees. This is 22 meters. And then geometry of the figure means sine 2.5 is equal to 22 meters divided by distance. Okay. So the distance is equal to, on solving this one, I get the answer. What is the value? 504.36. Why not 4.36 meters? Now we know, according to work energy theorem, work energy theorem, W is equal to delta E. Here we found out the delta E. Okay, so that is the work done. But work done is equal to F dot D, or mod F mod D cos theta. Here theta is equal to 180 degrees because work done by the friction. The friction does the work in the against, opposite to the direction of motion. That is why theta is equal to 180 degrees. The work done is equal to 1.8 into 10 to the power of 5 joules is equal to F friction times distance is equal to 5.4.36 times cos theta. Okay. To cos 180 degrees. Cos 180 is equal to -1. So this value becomes F friction is equal to 1.88 into 10 to the power of 5 divided by 504.36 into -1. So that gives the answer minus 373.39 newtons, or F friction is equal to minus 373 newtons. Okay. So this is how I did the problem. Just we have to use the law of conservation of energy and work energy theorem to get the answer. Hope this helps. Thank you. Bye-bye.